In this example, I'm going to use implicit differentiation to write an equation of the tangent line to the graph of y squared equals the natural log of xy, and I'm going to do so at the point E1. Okay, so remember when we're using implicit differentiation, the goal is to isolate the y prime, or the dy dx, on one side, and then the other side will be a nice expression that I can use to find the slope of the tangent line. Additionally, anytime that I differentiate a y term, I need to stick a y prime with it. Okay, so here I have y squared, so when I differentiate that, I'll get 2y, but of course I differentiated a y term, so let's go ahead and put a y prime with that. And that equals now the natural log of xy. Okay, well, how do I differentiate a natural log? Well, it's going to be u prime over u, which means it's going to be the derivative of this divided by this. Okay, so the derivative of this will include the product rule. So it's going to be the derivative of the first, which is 1, times the second, plus the first times the derivative of the second. So the derivative here is y is 1, but I need to put a y prime with that. And then, of course, I'm dividing by that, xy. So here's what this will look like for our first step. And I notice I have y prime in a couple of places on opposite sides of the equal sign. So I need to kind of maneuver here a little bit to get the y prime terms together and the non-y prime terms on the other side of the equation. So let's go ahead and start by multiplying both sides by xy. So that will cancel here. And on the left side, I'll end up with 2x y squared y prime equals y plus xy prime. And let's go ahead and subtract this xy prime from both sides so I can kind of get my y prime terms together. So 2x y squared y prime minus xy prime equals, well, it just looks like y. Okay, so let's go ahead now and factor that y prime out. So I have 2xy squared minus x, and that equals y. So whenever I divide both sides of my equation by 2xy squared minus x, it looks like that will finish getting my y prime by itself, and that will equal y over 2xy squared minus x. So here I have an expression that's going to give me the slope of my tangent line, and that ordered pair was E1, remember? So let's go ahead and plug this in and see what we get for our slope. So m equals y, which is 1, over 2 times x, which is e, times 1 squared, and then minus e. So I can kind of wrap that up a little bit. 1 over, so this 1 squared is like this. It looks like 2e minus e, which is just 1 over e. Alrighty, so I have my ordered pair here, and I have my slope. So let's go ahead and write the equation of this tangent line. We'll do so in point slope form. So y minus the y coordinate, and that y coordinate was 1, equals my slope, which is 1 over e, and then it'll be multiplied by x minus the x coordinate, which is e. So there's that tangent line equation written in point slope form. And let's go ahead and look at the graph of that to get an idea of what it looks like.